Hello everyone, this is Kalpana, working as an assistant professor in Artificial Intelligence and Data Science Department of SNS College of Engineering. Today we are going to discuss a topic on contiguous memory management. It is coming under the unit 3. It deals about memory management. Let's get into the topic. So, usually memory management is broadly classified into two types. One is contiguous memory management and another one is non-contiguous memory management. Okay, in non-contiguous memory management, we are dealing with fixed partition scheme and variable partition scheme. We'll see one by one. So, first we'll discuss about contiguous memory management. So, before getting into this topic, what is contiguous memory management, we should know the memory protection. Okay, so at a time simultaneously we are going to deal with many number of process. Like we at simultaneously, parallelly we are going to work with many different kinds of applications. So in order to not overlap with each other in memory, we need to protect we need to protect the memory of each and every process. So let's discuss how the memory protection is done here. So first, here your CPU, once the process is getting entered into the system, once if you're going to load the process into the main memory, your operating system is going to allocate two types of addresses. One is the base register, base address it is going to provide, and another one is the limit register, limit data it is going to provide. So base address is nothing but from where in main memory, from which location your data is going to get executed, starting address of the process, and the limit it gives the size of the it gives the size of the uh, process. Okay, so once this is being set, your CPU is going to deal with the instructions, which means it is going to execute the instruction one by one. So at that time, this CPU, your processor, is going to allocate the address, which is nothing but the logical address it is going to generate. Here, this logical address is something like it is going to just uniquely represent the exact memory of the process. Let's see how it deals with your physical address. So first your CPU is generating a logical address, and that is compared with the limit register. Let's say for example the logical address is 200 and the limit set is 3000. Okay, limit set is 3000. So both are compared. If it is less, it is going to add with the relocation register. This relocation register is nothing but the base address. Okay, let's say base address is 2000. That is the starting address of the process that is given by the operating system is 2000. So this 2000 is getting added with your 200, which gives 2200. Okay, so this is your physical address. Just be careful while calculating the physical address. It is the combination, or we say it is the sum of the logical address plus the base address. Logical address plus the base address gives your physical address. So totally you will get 2200. So in your main memory at 2200, uh, uh, this process is going to get executed, which means in your program, for it's kind of any data, um, if it deals with any data manipulation, if you want to store any kind of data, then at that time, for example, 2200 at location 2200, that particular data will be loaded in the main memory. Okay, so usually we calculate physical address with the help of logical address, and the logical address is generated by the processor, that is the CPU, and the base address and the size of the process will be set by the operating system once the process is loaded in the main memory. Okay, so next is we'll see what is contiguous memory management. So whenever a process asks to access your main memory, we allocate a contiguous segment, which means continuous. For example, your process 1 It starts with 1 and it ends with 200 MB. Let's say your second process P2, it is going to get loaded in 2001. Okay, and the third process, for example, it is getting ended in 300 and your P3 process is going to load from 301. So continuous memory is being allocated for this process. So this is called your contiguous memory management. We'll discuss elaborately about this memory management, contiguous memory management technique in the upcoming sessions. Thank you.